All right, let's take a trip. We're heading out about 15 million light years, right to the edge of the Hydra and Centaurus constellations. Our destination? One of the absolute jewels of the southern sky, Messier 83. You probably know it better as the Southern Pinwheel Galaxy. And from way out here, yeah, it looks pretty much perfect. A flawless, grand design spiral. But, looks can be deceiving. That serene, beautiful image is hiding a pretty wild secret. When astronomers zoomed in on its heart, they found something they totally did not expect, a cosmic puzzle that really makes you rethink what we know about galactic centers. So let's get properly acquainted with our cosmic cousin here. This is Messier 83, also known by its less catchy name, NGC 5236. And you can immediately see why we call it a cousin to the Milky Way. I mean, just look at it. This is an incredible view of those sprawling spiral arms, all lit up by the blue glow of super hot young stars. It's the textbook definition of a grand design spiral. Clear, perfectly formed, and, well, it looks so peaceful. So let's see how M83 really stacks up against us. It's a barred spiral, check, just like our own Milky Way. But take a look at that star formation rate. It's cranking out new stars at more than double our galaxy's pace. This incredible activity is really our first big clue that there is way more going on here than meets the eye. And all that weirdness, it really starts right at the center. For decades, astronomers just assumed that the brightest spot they saw was the nucleus. Makes sense, right? But as our telescopes got better, they realized the galaxy's core was a classic case of mistaken identity. Which, of course, leads to the big question in this whole investigation. If that super bright spot isn't the center, then where in the cosmos is it? And what on earth is happening in the heart of M83? Well, this is what they found. Not one center, not even two, but three different clumps of mass all jammed together in the core. Now, a galaxy is supposed to have one center of gravity, right? A single nucleus. Finding three is, well, it's like finding three pilots trying to fly the same airplane. It just shouldn't work. It's a recipe for total chaos. Okay, let's meet the suspects in our little cosmic crime scene. First up, you've got the optical nucleus, the ON. That's the super bright spot we see, but it turns out it's just a ridiculously dense cluster of stars. Then there's the kinematic center, or KC. This is the spot the galaxy's stars are actually orbiting around. And last, the real mystery guest, the hidden nucleus, or HN. It's a big clump of mass that's shrouded in dust, and some astronomers think it might be the leftover core of a small galaxy that M83 ate. So to solve this thing, astronomers had to act like cosmic detectives. They were gathering all these different types of clues, trying to piece together a story that made sense. The problem was, the clues were telling them completely different things. And here's where it gets really confusing. When they looked at the stars, their movement was smooth, orderly, rotating perfectly around that kinematic center. That tells you things are gravitationally stable. But the gas in the exact same area, it's a total chaotic mess, just a swirl of shock waves and violent streams of material. And here's the key takeaway. The gas is basically an unreliable witness. Why? Because the core of M83 is a starburst region. All those massive new stars are exploding as supernovae like crazy. These explosions have completely churned up the gas, scrambling the evidence, and basically erasing any hint of the real gravitational story underneath. The big breakthrough in the case didn't come from a telescope, but from a computer. A team of astronomers built this incredible simulation to see if they could recreate this bizarre triple nucleus. They needed to know, could these three things actually exist together, or was something else going on entirely? Okay, let's walk through what the simulation showed. At time 0, we have our three main players on the board: the kinematic center, the optical nucleus, and the hidden nucleus, plus a few smaller star clusters. Right at the beginning, they're all separate. Almost instantly, gravity starts doing its thing. Just 5.5 million years in, these objects are already yanking on each other, stripping stars away and forming these amazing tidal streams. They've been pulled into this inescapable cosmic dance. Fast forward to about 11 million years, and that dance has turned into a frantic spiral. The three nuclei are all orbiting a common point, but they're losing energy fast and spiraling inward. They are absolutely on a collision course. And there it is. At 16.2 million years, the simulation shows the three nuclei slamming together, merging into one single chaotic blob. This is the answer. What we're seeing in M83 today isn't some stable, weird, three-hearted system. No, it's a snapshot of a violent merger happening right now. Now, if we let that simulation run forward in time, we see that after about 127 million years, all that chaos finally dies down. The smaller star clusters get eaten up, and the core settles into a single, stable nucleus. So the mystery of the triple nucleus is solved. It was never a question of what these things were, but of when we were looking. This galactic pileup isn't just rearranging the furniture in the core, it's setting off a gigantic wave of star formation. And you know what happens when you get a lot of new massive stars, right? You inevitably get a whole lot of star death. 364. Just let that number sink in for a second. That is the number of confirmed supernova remnants, these shredded corpses of exploded stars that we have counted in M83. That is more than any other galaxy we have ever studied. Period. And this isn't just some ancient history either. This image shows you where we've seen 6 different supernovae go off in M83 just since the year 1900. It's a constant cosmic fireworks show, all fueled by that chaotic merger happening at its heart. So in the end, this messy, chaotic center in M83 is an incredible gift to science. It's this perfect, nearby laboratory where we can study galactic mergers, huge bursts of star formation, and the entire life cycle of stars on a massive scale. The violence and the chaos are exactly what make it so valuable. And that leaves us with a really fascinating thought. From far away, M83 looked absolutely perfect. But when we got up close, we found this violent collision hidden inside. It really makes you wonder, as our telescopes get better and we peer deeper into the universe, what other incredible secrets are just waiting for us, hidden in the hearts of galaxies we thought we already knew?